Let's take some time to look into the normal distribution which we would be using in our course. So first of all, what is a statistical distribution? A distribution is nothing but a model which is applied on your data or on your observations which explain how your data is structured. And by structured, I mean how the data points are spread across different value sets. So for example, if you measure the height of 1000 people, some will be short, some tall, some will be around the average height. So if you take the frequency counts of this data, it will form something called a distribution. And the shape of distribution will resemble a bell shape, and hence it's called a bell shape or a Gaussian distribution. And normal distribution is the most commonly occurring distribution in nature, hence it's used across a variety of different models, because by using another concept called the center limit theorem, we can take a series of observations and convert that into normal distribution as an approximation and use that for our purposes. So once again, a normal distribution is basically a bell-shaped distribution which is generally symmetrical around the mean. So for example, the mean here is the red line, and it is clustered, most of the points are clustered around the mean with fewer points on the edges. And we have the two most important parameters are the mean and standard deviation for this distribution. So mean is your central value and the standard deviation is how spread out the data is from the mean. So looking at this chart, you can see that about 68% of data falls within one standard deviation of the mean, which is this green line, and about 95% of data would fall between the two standard deviation bars shown here. And the more your standard deviation is, the more spread out your distribution or the shape would be. So let's investigate that. So this is a widget which I created for visualizing the distribution for this purpose, and you can see now that as an example, we have a mean of 5 and a standard deviation of 10. And if I increase the standard deviation to 20, it would spread out more across the x-axis. You can see that. And if I keep on increasing this value, it will spread out more. And what that means for us in terms of our inventory process is that the variation in terms of our lead time or demand will increase, and we have to subsequently model our other factors or parameters like safety stock, service level, etc. in the same manner. Now just coming back to the code, you can see that I have used NumPy as well as matplotlib.pyplot to basically plot the chart. And we would be using this np random normal function throughout the course to generate normal distributions. So in the real world, you'll probably need to use a variety of different distributions to model lead time and demand. But for this course, I would focus on the normal distribution, the mean and standard deviation concepts, and we will be applying these heavily across the course.